Starting right now. All right, number 21 and 22 today. All right, get everyone set up, organized. All right, I give you this polynomial C of m, and then when C of m equal to 0. So I got to take this one, set it equal to 0, and see what we can do with it. Every time I would tell you guys, since it's multiple choice, take your multiple choice, try to plug it in. But I probably would advise against it because part of the responses, multiple choices have eyes in it, and I don't know how your calculator rolls with eyes. All right, I don't deal with calculators with the eyes either. So, all right, so we're going to have to, looks like, factor it so we can solve any GCF up here. Let's go. Here we go, 18, any GCF? Not here, huh? Garbage. 11, any GCF? Nope. How many terms are there in this one? 4, how many terms? Oh boy, I'm going to get fired up here soon. 11, how many terms? 4 terms. No GCF, 4 terms. That automatically equals what method of factoring for us in here? 2. Grouping. Nice job. So let's group these suckers up. See what we come out with. 3. What do you want to take out of the first one?
M squared.
M squared. What are you left with?
M minus 2.
M minus 2. Nice job. Now, whoever gets next up, make sure whatever you take out, I get an M minus 2 left in the parentheses. That's the purpose of grouping. What do you want to take out of the second one? Let's go, 16. Take a 4 out. What are you left with? Nice job. Please make sure you guys are aware you are not done grouping yet. All right, this drove me nuts when we did this in the second unit. You are not done grouping. Finish it now. 7, what goes in the first one? M squared plus 4, and how about in the second one?
M minus 2.
Nice job. Anybody, hopefully we're at this point, way beyond this point, can you factor M squared plus 4? No, done. At least we know one answer, right? M equals 2. There's one answer. Unfortunately, that doesn't help us out if you look at your multiple choices. So now we have to go and solve M squared plus 4 equals 0. What happens when I move the 4 over? Ooh, yeah. M squared equals negative 4. And when I take the square root of both sides, what's the square root of a negative 4? 2i, but good, I'm hearing it. I'm hearing it because you're taking the square root. Plus or minus 2i. And I told you, this is brutal. You forget to put the plus or minus and just put 2i? Yeah, that answer's there. All right, it's brutal. All right, so I end up with choice 4, plus or minus 2i and 2. All right, I'm challenging you now. Did not even need to do any factoring whatsoever. I did want to do it, obviously, to go review with you. But as you read the problem, how did I know it was going to be answer 4? Here we go. Yeah! What's the highest exponent? What's the highest exponent? 3, which means that tells me there's 3 choices. Look at all of them. How many choices are here on choice 1? 2. 1 choice. 2 choices. Only one with 3 is number 4. Okay? Everyone good there? All right, 22. We're hopping back on the Ferris wheel with this sine equation. Ooh, but guys, there's a lot of numbers flying there. What? You're not whining, are you? All right, good. How many seconds does it take to go bottom to top? In other words, what am I asking you to find here? Ooh. Well, if I was looking for the min or the max, that'd be the actual height. I'm not looking for that. I'm looking for how many seconds it takes. Period. Let's keep this discussion going. I don't need the full period here. Why not? I'm only going from bottom to top, so I only need half of it. Everyone see that? All right. So now we figured out we needed the half of the period, but, oh boy. Oh, hold on. I was going to ask people because it took me like 4 people in period 5 to finally get it. Drove me nuts. 2. Period formula. Dig deep. And it only takes 1 in here. Next concern is what number up there is the B? Whew, there's a lot going on up there. Which one is the B value up there? Oh boy, come on. Dig deep. 8. Come on. Pi over 45, everybody. Quickly, before we solve this, quickly. The 150. Amplitude, A value. Pi over 45, that's my frequency, my B value. Ooh, do we remember what that was? Which way? Left and right. Yep, the phase shift. And then this was my 160. Vertical shift. Yep. All right, so go ahead. What's the period of this one? Skip, flip, cartwheel, we know the deal. 2 pi times 45 over pi. 90. But again, that's a choice. Wants to suck you right in. But that's bottom to bottom. From bottom to the top of the wheel, what do you got for me here if you follow along? 14, what do you have? 14? 90 is the period, but not my final answer. Why, Mike? Yep, to go from bottom to top of the wheel. Okay, everybody good? Questions there? All right, nice job. We're actually almost done with this thing, I think. We only have a couple blanks left, I think. The big dog in the back. And all right, I think I've announced it, but just in case you weren't here, you didn't hear it, Wednesday's the unit test, and that's where we end Algebra 2. And then we start Thursday, Friday reviewing, and then we get back from break. It is all on like Donkey Kong, all right, to get you ready. Okay? Last Saturday, thanks for asking. It was fine. Didn't live up to my expectations, but it was fine. I don't want to call it hot chocolate. I'd probably call it lukewarm chocolate, but. Ooh, 13 days of review when we get back. 13 days of review. All right, here's what we're going to be doing today, and you really got to focus in here and help me out by participating. What we watched yesterday with the swimming of dolphins, whatever you thought about it, whatever. All right, it's done, it's over with. Here's what I got to show you today, and you got to do for me today, is mathematically decide if the treatment works or it's by random chance. Okay, I'm going to show you different techniques to do that. All right, I do not like the way your packet is set up. So you'll see me just skipping around from pages to pages today. All right, because I do not like the way it's set up. And honestly, some of this stuff is just nonsense. It's a time waster. All right, I want to get to the meat of it, what you need to know for the test and the Regents exam. So I'm actually going to start on page 28 today. Okay, page 28. I'm not going to have you waste time and do a box and whisker plot. It's a waste of time. You're never going to have to do one. And I got to change this for next year. Okay, so I will let you go right now. The worst part about these problems is probably reading them, because they always come from some background story about what we're testing and how many people we're going to divide up into. So Ava, I think that's that one. Yeah.
Who made that? Who made? Who spelled that name like that?
I don't know.
Didn't you guys make this package?
We do, yeah. But I didn't make the problem. All right. We just put it together. Okay, so read about Ava and her thoughts and theories on energy drinks, please, quickly, and then we'll get into it. Okay, so we get the gist of what she's doing here. She thinks if you drink an energy drink, you're going to read faster.
Yeah.
Okay, so she had 20 people, divide them up into 2 groups of 10. Group 1 got the energy drink, and here are their times in seconds that they read a paragraph. And then she gave group 2 the cola. That's our control group, whatever you want to call it, and those are their times it took to read a paragraph. So before we do any testing, she thinks the energy drinks make students read faster. Based on this chart, is that true? Based on this chart, is that true? That reading, you get to read faster given an energy drink. Before we do any testing, is that true? Because I see some yeses and I see some nos. I don't think it's true. Every single time here should be faster than group 2. Is that the case?
No.
If it truly does, we don't have to do any testing. Everybody that got the energy drink should be reading faster than anybody in group 2. And can you find people in group 2 that read faster than in group 1? Yeah, you're darn right. So right now, this is why she's incorrect. All right, right now, why is she incorrect? There are people in the cola group that read faster than the energy group. Okay. So right now, I don't believe her. But ready. Everyone agree, on average, though, if you drank the energy group, you read faster than the cola group, on average. Because take a look, what were the averages? 17.7 for the energy and 19.1 for the cola. So on average, yeah. But is that because of the energy drink or not? That's what we have to decide. Or is it just by, what did we talk yesterday with the Dolphins? Random chance. Okay, so that's what we're going to be calculating right now, and I'm going to show you how to figure out. So on average, is it really because of the energy or is it random chance? First thing we need to do, is calculate the differences in the averages. All right, this is the first step in seeing if the treatment worked or was it by random chance. The first thing we do is calculate the difference. We called that yesterday our observed difference. Remember that with the Dolphins, observed difference. That's the first step in here, and that is the difference between the means. And how do you know which one to do first and which one to do second? Everyone see the simulation we did? Group 1 minus group 2. All right, they'll usually tell you what order to put them in. So here's my first question. Here you go, number 13. What was the means of group 1 and 2? The average of groups 1 and 2. 13? Group 1's mean, what was it? According to the chart. 17.7 minus group 2's 19.1. And when you're ready, Rachel, let me know what that number ends up being. Negative 1.4. Okay? And here's what it means as part of the problem goes. On average, group 1 read 1.4 seconds faster than group 2. That's what that means. So is this difference because of the energy drink or not? Next step, after you've calculated your observed difference, you go to the simulation, which will always be done for you, and you locate where that difference is on the simulation. So everyone take a peek and take a look at where negative 1.4 was. Make a mark of it if you want. I can't read a thing here. It's about 2 over from 1.6. So I don't know. We're just going to And here's what we have to determine. Is that location unusual or not compared to the rest? Because if it's unusual, it was because of the energy drink, but if it was just part of this middle group, it was by random chance. And if you remember yesterday, ready? Stay with me here. If you remember yesterday, and you don't have to write this part down, with the Dolphins, we calculated what interval again? What percentage interval? we calculated a confidence interval, which was what percent? 95%. And I'm just going to make a little diagram. Don't have to worry about anything. And we said if your number fell in the 95%, was it random or unusual? Anybody remember from yesterday? If it fell within that 95% range, was it random or unusual? If within the confidence interval, it was random. Okay, if it falls outside the confidence interval, it was unusual, meaning the treatment worked. Everybody good? Okay, so here's the problem, though, we're all going to have today. Remember how to find that confidence interval? We took standard deviation. We took the mean. Thanks, guys. Have a good weekend. Remember that? We took standard deviation and the mean, found margin of error. That's missing here, isn't it? I don't have that. And I highly doubt any of you want to just start taking all of these and how many there were and creating lists. Anybody want to do that? No, me neither. So how the heck can we find it if I don't have a confidence interval? Well, ready? 95%. How many percent's left over? 5, right? And it's got to go divided up evenly between these two regions. So what percent are these regions going to be? Yeah, 2.5. So what we're going to calculate right now is if this score, if it's at or below 2.5%, it's unusual. If it's more than 2.5%, it's going to fall within that confidence interval. So how do we do that? How many scores are there here? You don't have to count them up, just read. How many scores did I simulate? 232. So out of those 232, here's where you're going to have to do a little work with your group. How many are at or below negative 1.4? So you're going to have to go over, look at the frequencies, how many times it occurs. So go ahead with your group right now. We'll see if we can come up with a consensus. How many are at or below negative 1.4? And we'll see if that's 2.5% of them. Count them up. Just don't count the number of bars. Count the frequency over on the left side too, how many times it happens. And we'll see if we can come to a class agreement. Can we get a debate going how many there are? At or below? What are we looking at? And if you're off by 1 or 2, that's fine. We don't need exact, but come pretty close here. Can I get reports out by other groups here? How many? I got a what in the back? 24, 25, 22, 22, 24. At or below, remember, at or below. So we're getting about, I'm going to say, if I put them all together here, we're getting about 24. If I take the 22 to 25, the 24s, 24, all right? It's not going to affect it at all, don't worry. It's 24. Okay, so 24 out of the 232 are at or below. What percent of that is, what percent of scores are that then? About what? It's about 10.3%. So you tell me, would that fall in our confidence interval or outside if it's 10.3% of the scores are at or below? It's going to fall within this range, isn't it? Because 2.5% are over here. But we got 10, so that means we're creeping into this 95 now. Do we see how that works? Yes? No? Okay, so before I answer the question, was it because of the energy drinks or a random chance? Random chance. All right, that the one group read a little faster than the other. But let's answer the question there. Ayova is actually saying that I look, sorry, I was making an attempt. Calm down. All right, I was making an attempt. Poor girl, guy, I don't know. All right. She decided that the difference in the mean reading times is not an unusual occurrence. And she's correct. Why? Because negative 1.4 fell within what? Fell within, what do we call this? Our 95% confidence interval. Yep. And that's what we're going to be doing. You guys find the difference between the means, look where it is on the simulation, see if it's in that 2.5% or not. Okay, if it is, it's unusual and it worked. If it's not unusual, it's not significant. It's by random chance. No, absolutely not. Seriously. Not going to get any harder. You just have to check if it falls within the confidence interval or not. Questions? All right, one doesn't make you great. All right, let's go to page 27 with the batteries. And you can talk about Max and his science project. Fair project. All right, read through about our boy Max. Do I have anything planned for the weekend? I have to partake in an all-day workshop tomorrow, and I think then tomorrow night we're taking the kiddos to Lights in the Park and driving through. Anybody else? Big plans? Before we go to the batteries, anybody else? Big plans? No? Okay. All right, so here we go. Here's what Max did. All right, here we go. He took 30 AA's and he took 30 AAA batteries and he see how many paper clips it could hold. All right, and he made this beautiful box and whisker plot. Okay? So based on these plots, why is it incorrect for Max to say AA batteries will always hold more? Just based on the box and whisker, why is it incorrect for him to say AA batteries always hold more? Go ahead. You see it. You see it. If they did actually hold more, what would you notice about this box and whisker for the AA's? It would be completely ahead of the AAA batteries, right? Okay, so why is it incorrect? Because there's AA batteries that hold more paper clips. Or AAA, excuse me.
Oh, yes, I did.
But on average, if you read the problem, on average, the AA batteries do hold more, but is that because of the batteries or just by some random chance? Ready to test. First step, find your observed difference. You guys, last problem, calculated it for me. I actually gave it to you in this problem. So go ahead, go back, reread. What is my observed difference in this problem? The difference in the means. What do you got for me? 3.8. He found that the 30 AA batteries held on average 3.8 more than the, so right there, that 3.8, that's your observed difference. And then he did a simulation, which you can go to right at the bottom of that page, I believe. Take a look at the simulation. Locate where 3.8 is on the simulation. I think we know the answer right away, but we still mathematically have to show it. Everyone see where 3.8 would lie? Somewhere in there. I'll do this one with you. How many are at or above in this case? At or above 3.8? 3. How many are at or above 3.8? 2. I don't know what that was, but 2 out of, don't count the dots, read the problem. How many times did I do the simulation? How many times? 100 times. So 2 out of 100. Oh boy, 2 out of 100. About what percent? All right, 2%. All right, let's talk, because this is where we usually sometimes get confused. We can find it, but is that unusual or is that random chance? Unusual. Why? Because it falls into that 2.5%, right? All right, so this, let's answer the question. Explain why, based that Max can conclude there's statistically significant evidence. That's because, what was it, 3.8 falls not within, but outside our 95% confidence interval. Questions from you guys? Okay. I want to show you why this is so important. Go to your Regents exam. They ask one of these questions every year. And then I'm going to have you do one on your own. Points are what? This question or? Yeah, this would be a 4-pointer. This is a 4-pointer.
Right, that's what I'm saying.
Okay, so it looks like we're going to play music during a quiz. And here are the results of 16 students broken up into 2 groups of 8. Yep. One played classical, the other played rap music. The results of the quiz are as follows. So there's the classical, there's the rap. All good there? Okay. John correctly rounded the difference of the means as 7. How do you do it? How do you get that 7? You got to show how he got the 7. He said the difference in the means was 7. So where did he get that 7 from and how was it calculated? Okay, we found the what of classical and rap. He found the means. Everybody go ahead. So the classical mean and the rap mean. Anybody finding the classical? Actually, I just going to ask you. When you get it, classical mean 6. What was the classical mean? Ooh. Classical? Redo that, Mary. You get better than that. Add them all up, divide by 8. Well, Mary's doing that. What about the rap one? 16. What about the rap one? 0.625. I'll round it in a second. What do you got now, Mary? 82. Yep. All right, still waiting. How do you get the 7? He subtracted them. Yep. So he said the difference was equal to 82 minus that, and that rounds to 7. Okay, guys, this is because the next question is becoming more and more frequent on the Regents exams, and that is, what does this 7 represent as far as the problem goes? And I don't want to hear difference of the means. What does that 7 mean as far as the scores, the classical, the rap go? What's that 7 represent? That's what I'm asking you here, and it's being asked more and more lately. What's the 7 represent? Any thoughts? Who did better overall? Classical. So this is what the 7 is saying. on average, because that's what it is, it's an average, those who listened to classical did. Anybody want to finish this? Not easy, not percent. That's 7 points. 7 points better. So those who, on average, those who listened to classical did 7 points better. All right. All right. Let's determine, is there any significance in this? Is there any significant difference in quiz scores? So everyone find your 7, right? Find your 7. On the simulation, find your 7. How many are at or above 7? Number 1, at or above 7. All right, how many? 4 out of, how many times did I do this? Woo, 250 times. 4 out of 250. About what percent would that be? 17. 1.6%. All right, what's that number telling me? Is there significant difference? 1.6%. Is there significant difference? Where does it fall? 2.5, right? Falls outside the 95%. So yes, there is significant difference. It's not by chance. And really the response is the same all the time. Yes, because it falls outside the 95% confidence interval. So yes, there is significant difference because it falls outside the confidence interval. That's not bad for 4 points, is it? We just got to remember that it's a little under 6 weeks. Bless you. Whew. Easy, Tiger. Easy. Okay, your group by yourself are going to go to, I'm not too sure what page that is, 30 maybe? I don't know. Keep going, Mary. Flip it over. Keep going forward. Right there, page 30, yep. When you and your group have it, call me over, or individually if you have it, call me over, all right? Please read carefully. You're going to have to explain what it means and everything on this one. Great problem. Find it, explain what it means, and then see if it's significant or not. You got this one. You're doing a great job.